All right, week 6, day 1. We have added and subtracted rationals. We've multiplied and divided rationals. And this right here, my Bitmoji this week. On my way. We are on our way to the finish, guys. We are getting closer. So this week and next week, we will be solving rational equations. Okay? As always, pause and play when you need to. And I am going to tell you that this is the week where we've been discussing what x cannot be for the last 2 weeks. This is the week to why we have been discussing what x cannot be. Okay? So, right here at the start, it says if x over 7 equals 4 over 7, then here's my question. What does x equal? So if x over 7 equals 4 over 7, what does x equal? Well, if you're sitting there to yourself, well, if x over 7 has to equal 4 over 7, they have to be equal. Well, then, guess what? Oh, I didn't know there was a question mark down there. Okay, so x has to equal 4. Okay, so that's going to be a big key thing here in the next couple of weeks, is that if our denominators are the same, then that means that our numerators are equal. Okay? So, using that concept, we are going to be solving a few equations. Alright? So, here's a rational equation. 2x plus 3 divided by x squared minus 1 plus 3 divided by x squared minus 1 equals 14x divided by x squared minus 1. What I'm going to ask you first, before I even begin my question, I want to know, what can x not equal? Okay? Across here, every single one of my denominators are the same. If I set that denominator equal to 0, just to see, x squared minus 1 equals 0. Well, that means x squared equals 1. And if I'm trying to find what x can't be and I square root both sides, well then x cannot be, if I square root, plus or minus 1. So I cannot have an answer of positive or negative 1 for the value of x. Okay? So again, on the left side, these are the same. Well, if those are the same, we know, ignoring this equal sign over here, so if I just do this for a minute, throw up my screen shade, if I ignore that equal sign for a minute, okay, just look here at this left side. Well, we know from last week, if I have a common denominator and they're the same, well, I can combine these together. 2x plus 3 plus a 3 means that on the left I have 2x plus 6 divided by x squared minus, not plus, minus 1. Okay? Then I'm going to add, well, we have a right side of the equation equals 14x divided by x squared minus 1. Well, on the first page, we learned that, hey, if the denominators are equal, my denominators are equal, that means that my numerators will be equal. So 2x plus 6 equals 14x. Well, can I solve this equation? Well, I hope so. Subtract 2x, 6 equals 12x. When I divide by 12, 6 over 12 is 1/2. Now, here's the beauty of this. Do you have to check your answer? Sure, you can check it, make sure it works. I can promise you it will. If it is the correct answer, it will make that equation up there true. So if you want to take your time and put that in there and check it, that's great. We also can use something to our advantage. X cannot be 1 or negative 1. Is this 1/2 1 or negative 1? It is not. So guess what? This should work. Okay, that is our answer. X equals 1/2. Okay, so here's a second equation. X minus 8 equals 9x. How about I try this again? X minus 8 over 2x plus 2 equals 9x over 2x plus 2. And I'm going to say again, what can x not equal first? Okay, I do this first because, well, then that's going to save me some time at the end. And I want to do it at the beginning because it's for the beginning of the problem when it matters what x cannot be. Okay, so again, to find the value of what x cannot be, if I take the denominator, because they happen to both already be the same, and set them equal to 0, I want to know, okay, well, 2x equals negative 2, so I cannot have a value of negative 1, okay? So x cannot equal negative 1. Again, because my denominators are equal here, well, what does that mean? My denominators are equal, so my numerators are going to be equal. X minus 8 equals 9x. Solve that equation. Right? So we get an answer of x equals negative 1. We talked about extraneous solutions back when we were solving square root questions. Extraneous solutions. I probably spelled that wrong, but that's okay. Teach math, guys. Teach math. Extraneous solutions. Now, just a reminder, an extraneous solution is an answer that cannot be an answer. Well, this right here, x equals negative 1, is an example of this right here. It's an answer that cannot be an answer. Well, why not? Because up here, x cannot equal negative 1. Okay, so because x cannot equal negative 1, that means my one answer is extraneous. It doesn't work. So what is the actual solution to this? It is no solution. All right. Next question. 6 over a equals a plus 1. So I'm going to ask you a question that you're going to answer to yourself here. What's something I can do to make this so it's doable? I only have one fraction. Hopefully, some of you right now are going, hey, I can put this fraction over 1, and now look at that. I have a fraction on the left, and I have a fraction on the right. Now, on our last two examples here, 3 examples even, counting the main first page here. Okay, what was important? Well, it was important that the denominators were equal so the numerators could equal. Okay, same thing on this next page. It was important that these denominators were equal so that the numerators could be equal. This example here, the denominators were equal so the numerators could be equal. Are the denominators equal? Well, no. So how am I going to get them to be a common denominator here? Well, no different than how when we added and subtracted fractions. This here is a, this here is 1. Oh, well, I can multiply this side by a over a. Now, because this a over a is a form of 1, we don't have to multiply both sides of the equation, okay? Because multiplying by 1 is the exact same thing that's left. We're just changing the look and not the meaning. Okay, so on the left we have 6 over a. On the right, remember, you're going to have to distribute this a to both terms, okay? So on the right, we have a squared plus a all over a, okay? Remember, our goal here was that our denominators are equal. Well, once the denominators are equal, well, then those numerators can now equal. Ooh, if a squared, or if 6 equals a squared plus a, how am I going to find the values of x, or a, right here? And hey, before I start, I'm going to actually stop right here and say, hey, what can a not equal? And because a is a single variable on the denominator, a can't be 0. Okay, so when I go back to here, my 6 equals a squared plus a. Because I have this a squared and I have this a here in the problem, we're going to solve by factoring, y'all. So, I'm going to subtract by 6 so that I have a squared plus a minus 6 equals 0. I'm going to stop here because I think you all should know how to factor that trinomial on the left. A squared plus a minus 6. Find what multiplies the negative 6. Add to 0, and I want you to factor that side. Alright, so I factored that left side so that I had a plus 3 and a minus 2. Notice on every single step I have that equals 0. So every single step along the way here, it is equal to 0. Okay? So I'm at that point where I'm going to say, hey, I have to find my values of a. If I set them equal to 0, I end up with a is -3 and a is 2. Well, now because neither of those is my a cannot equal value, that means both of these are my solution, and that can happen. You can have two answers. If you were to check both of those answers up there at the beginning, they will indeed work. Okay, so here's another example for you. So if I get these to have a common denominator, I have a 3y on the left, and I have a y on the right hand side. If I multiply this by 3, so that I now have a -9 over 3y equals a -18 over 3y. How about, yep, there we go, 18 over 3y. Is there any way that -9 over 3y can be the same thing as -18 over 3y? Right here, what can y not equal? Well, y cannot equal 0. My denominators are equal. If I try to set those numerators equal, -9 equals -18. Is that possible? Well, hopefully you said, nope, that is not possible at all. -9 cannot equal -18. I didn't even get a value for y, so no solution. Okay. Next example, 2 minus 3 over x equals 5 over x. What I want you to notice here is that, hey, these two terms right here, I'm going to leave the negative with the 3x, 3 over x, they're a like term, but they're on opposite sides of the equal sign. Well, can I move terms around just like I solved earlier and moved a 6 to the other side to make it equal to 0? Yes, we can. Okay, so this -3 over x, well, I can add a 3 over x to the left side, and I can add a 3 over x to the right side. So that now I have this equation, 2 equals, because these are like terms right here. Let's see if I can, there we go. Those are like terms, the 5 and the 3 have a like denominator, I should say. I now have 8 over x. Hey, I want you to get a common denominator and find what x should be. Well, hopefully you multiplied that left side by x so that you had a common denominator of x. Hey, now those numerators are equal. What can x not equal? Well, x cannot equal 0. When I set those numerators equal, 2x equals 8, I'm going to get x equals 4, and because 4 is not 0, x equals 4 works. I want you to get a common denominator and find out w here. I'm going to unpause it step by step. Alright, to get those denominators to be equal, there are the forms of 1 on each side of my equation that we want to equal or multiply by. Here is what you get when you multiply. I want to know, hey, what can w not equal? Hey, w cannot equal 0. It's the only value. Solve that equation. Alright, so we got this w equals 1. W equals 1 is not my cannot equal 0. So it indeed works. Hey, again, if you need some assistance, make sure you fill out that tutoring link Monday and Thursday this week.